Hello, everyone. I hope you're all doing well. I live in San Francisco. I used to live in London a while back. I just flew in from Zambia. I landed here yesterday, and it kind of feels like almost immediate. I feel the need to talk about the weather. So happy to be back here, GraphQL London. The first time I did a talk was 2019. At the time, GraphQL London was hosted by Twitter, and I spoke about automating GraphQL schema generation. So good to be back after a few more years of doing GraphQL. And today we'll be talking about persisted queries at scale. We'll get into what that means exactly. I went back and forth on the title of the talk, but I think this captures the essence of what we'll be talking about. So before we get started, I'll tell you a bit of a fun story. As I mentioned, I was just in Zambia. This was on a Sunday. Backstory is on Friday, I had lost my phone. And I was supposed to be flying here on Sunday, more like Monday morning at like 2 a.m. And I was just about to get on a safari. This is about 3 p.m. This is my first time at a safari, so I'm super excited. And then I get a call. And it was Qatar Airlines calling me, informing me that my flight was rescheduled. They couldn't get in touch with me. And would I be able to go to the airport in 30 minutes? I could not make that flight, but I spent the day at Lusaka National Park, which is one of the smaller national parks in Zambia. It's there to try and promote local tourism. So this is me and my siblings. We saw a giraffe. There weren't that many animals in there because it's much smaller and it's just recently opened. But yeah, I was super excited to see the giraffe. I might have jumped higher than it. But yeah, so happy that I actually made it here. So next, I'll tell you a little bit about the agenda. So I'll tell you about me, and then we'll talk about GraphQL. And then after that, we'll go into executing GraphQL queries. We'll chat a lot about persisted queries. And then we'll also dive deeper into the ID and how we can utilize that to unlock the power of persisted queries. So we'll talk about things like visibility, rate limiting, breaking changes, incidents. I might have actually scrapped that one off, and then trade-offs and a bit of a summary. So these are quite a lot of topics that we're going to go through. So I won't be diving extremely deep into each topic, but we'll just sort of get a high-level overview of how we can use persisted queries to tackle some of these challenges that we might face when operating a GraphQL service. Okay, that's the outline of the talk. Any questions so far? Let's get going. So, hello, hi. My name is Haggai. Sometimes I wear my glasses upside down. Helps me to see better when my eyes are tired. As I mentioned, I was born in Zambia. I lived there until I was 18. In 2018, I moved to California, where I studied electrical engineering and computer sciences. I actually started off as a civil engineer, so if we have any civil engineers, we can chat. I used to work at Twitter UK, where I was a senior software engineer. I worked both at Twitter UK, and then I moved to San Francisco, where I was for the past 2 years. And as Jared mentioned, I worked on the API infrastructure team, and we did GraphQL at Twitter. I joined the team right as we were taking GraphQL from the ground, and two of my colleagues are actually here. We scaled GraphQL from inception to something like, I think the number was like 700 billion requests per day, or 500,000 requests per second, 500,000 requests per second. So big scale. In about a week and a half, I'll be joining Roblox Corporation as a senior software engineer. I'll be doing full stack on their account integrity team. Okay, outside of all of this, I also enjoy teaching. So I've taught for Code First Girls here in London. and Afrofem coders, which is similar to Code for Skills, but for women in sub-Saharan Africa. And in Zambia, I also own a company called Tafika Tickets. Okay, so let's get started. Let's talk about GraphQL. Can I get a show of hands if you know what this is, what GraphQL is? Okay, I was expecting more hands, but that's good. I have some slides. Maybe let's jump to the last question. Can you get your hand up if you are currently operating a GraphQL service in production? Okay, excellent. Okay, so let's talk about GraphQL. Okay, so I might say something like GraphQL is a client-server API specification. And what I mean by that, down here we've got the classic client-server architecture. In between we've got the internet, and on either side we've got the client and the server, right? So the client can be anything like your mobile application, a website, or user interface, and the server is going to be the thing that's accepting requests for data and returning back that data from when the client asks for it. So by saying GraphQL is a client-server API specification, I mean this in the sense that it's similar to REST APIs, right? It's how we specify how the server and the client are going to exchange data. Okay, so for a more textbook definition of GraphQL, GraphQL is a query language for the API, so similar to how SQL is a query language for a database, GraphQL for our API. For the server, GraphQL is also a runtime to fulfill the requests that are coming in from the client. It allows us to describe our data using a typed schema, and having a schema allows the client to ask for exactly the data that it wants. Because we have a schema that declares the data that the client can return, the client is able to ask for specifically what data they want. And with that, we get back predictable results. For this last point, I put it on the server side, but it doesn't really get bucketed into one of these categories. But GraphQL also allows us to build powerful developer tools, and we'll kind of see some of that play out through the talk today. All right, this is a more visual representation. So on the right-hand side there, your left, my right, we've got a visual representation of describing our data here. So this is a type called project, and this is GraphQL SDL. So this is the schema, and here we can write a query against the schema. So we're asking for the tagline field on the project object, and then we can get back our results. And as you can see here, the response that we get back mirrors the request that was sent. Okay, so that is GraphQL in a nutshell. So now we're going to start talking about getting into the persisted queries and whatnot. But first, let's talk about how we can execute GraphQL queries. So here we have, client and server. We might send a string query to the server. This is the same query that we saw on the previous slides. And the server might return our response. So this is kind of like, if you're just getting started with GraphQL, you might do something like this. That request, it can be, GraphQL is protocol agnostic, so you can send it through HTTP or whatever protocol you want to use. And we send the query text. This thing is called a GraphQL document. I might use document and query interchangeably, but I'm going to mean the actual GraphQL string query that we're sending to the server. Okay, so that's one way to do it. Now, we might take the same query string that we just saw here, the one that the client is sending. And one thing we can do with it is run it through a deterministic hashing algorithm. We might do things like normalizing the string so that white space and all of that doesn't matter. So you can run it through a hashing algorithm, and on the other end, what you end up with is an ID, right? And we can tag this ID with like, extra bits of information to store that we can use against the query, such as what is the client that is using it? Is it in development or production, and things like that. But in essence here, we want to walk away with an ID. So I've actually seen a few implementations of this strategy. Apollo is an interesting one. So with Apollo server, you get the same query, run it through a deterministic hashing algorithm. Both the client and the server are capable of doing, and the server will cache it in temporary storage. And then TTLs and whatnot, it might expire. But yeah, so that's one strategy. You can sort of like cache it temporarily, or you can do it permanently at development time, right? For this talk, we're going to be assuming permanent document storage. Okay, so once we have the ID, we can then send a GraphQL request from the client, but this time, instead of sending the query string, we have the ID. When the server receives that request, it's going to look up the ID in our storage. We get the actual document from the storage, right? And now we can do validation and everything. And then we can have a response. Okay, how does this look so far? Good, I see smiles. Okay, so the next question we might ask is, well, why would we do that? Why don't we just keep the vanilla query string, right? It's a good question. So one of the reasons you might opt to do persisted queries is maybe you want to protect your API service against malicious queries. If your API is open to anyone writing requests against it and inspecting your schema, you might get poisonous queries like recursive queries and all of that. So you might want to prevent that. Or maybe you're just interested in making your GraphQL service private. So you don't want to expose your schema, and you're just going to lock down the possible permutations of executable queries. So no ID, no data. As we begin to scale our GraphQL services, queries might get pretty big. And if you're sending a query string across the wire, that might actually increase your latency, right? So you might swap out the actual text of the query with an ID. And then you can walk away with lower latencies because we're transmitting less data on the inbound request. Okay, so another thing that we can do with persisted queries is that you might want to do this to save some time when you're executing the query. So things such as validation. If we consult the GraphQL specification, there's, queries must always be validated at some point. You can do it at runtime, right before you execute the query, as would be the case with a string query. Or the specification also allows us to execute queries that were known to be correct or valid at some point in time. So we can validate our queries as we put them into the document store. Okay, so these are some of the reasons you might want to go this route, but obviously not exhaustive. So next, I'm going to talk about some of the challenges that we might face when we run a GraphQL service. And then we'll look into ways in which we can utilize the power of persisted queries to tackle some of these problems. Okay, so GraphQL in general as a whole, especially when comparing it to like REST APIs and whatnot, it sort of creates this black box, right? When you had a REST API, you had individual teams that own the entire workflow of the inbound requests coming into there. So they'll have everything from, metrics, latency, handling errors, and all of that stuff. But with GraphQL, they sort of hand over that power to you. So the GraphQL team is now responsible for unveiling this black box and giving developers visibility into it. The other thing is rate limiting. This is a fun topic, especially for GraphQL. So how do we reason about rate limiting a single endpoint that exposes all of our data? What about rapid iterations and breaking changes? You've got a single GraphQL team, perhaps hundreds of developers who are contributing to it. How do you handle this? What about root cause analysis? When there's an error, how do you drill down into that error and actually discover different individual teams that should be taking care of an incident? What about query evolution and life cycles? You've got queries coming in. How do you reason about how they evolve over time? So in general, all of these things for the GraphQL team, you kind of stack as like this human in the middle. And you get questions coming in from clients that are consuming the API and also developers that are feeding data or adding data into your API. Okay, so now we're going to go into unlocking the power of the ID. But I kind of feel like this is a good case of flipping Uncle Ben from Spider-Man, his famous quote, "With great power comes great responsibility." When we assign such responsibility to the document ID, it's now responsible for discovering the queries that we need to execute. We can unveil great power. Okay, so the first thing we'll talk about is how we can get insightful visibility for our requests that are coming into the API. So I sort of mentioned this earlier, but when we store our persisted queries, we can tag them with useful metadata to answer some questions. For example, what is the client that owns that request? Is this document perhaps in development or production? Is this a document that sort of like has evolved over time? We've added new fields to it, but in general, it's the same document that's like maybe servicing. You can think of like a profile timeline on Twitter. You might have a document that sort of represents the profile timeline as it evolves over time. We can also use the document IDs to track metrics such as success rates, latency, or RPS. And this is actually kind of key, right? Because if you imagine a GraphQL string query that's coming inbound, how do you reason about the success rate of that string over time? You need to associate something to it that you can use to track some of these metrics. So really, it kind of like gives you this extra cardinality, right? An extra layer of cardinality that you can then use to keep track of some of the finer grained metrics, such as field usage, which you would get even if you're using a string query. But now you also get more coarse grained metrics that you can tag to sort of look at the performance of the document as a whole over time. Okay, so here is a little bit of a diagram. I don't know if you can see the bottom because of the box speakers there, but what we have here, this is an example looking at requests per second for a document called project tagline. This is the query we saw earlier. So the first two bars here are sort of like showing this is both production version of this document for the iOS client. And we can see the first one having more requests. The second one has got less. So this might signify something like we've made an update to the document and X percentage of the clients have updated the app, and the other ones are using the previous version of the document. And then we have the same here for web. So here we have two clients, and then we have a document that's like in development for however clients, that's like a wildcard there. But this is just sort of an example. We can do similar things for like success rates or latency or any other key metrics that we want to track. Okay, so that's a little bit about metrics. The next topic we're going to look at is rate limiting. I kind of mentioned this is like one of my favorite topics. I remember starting my job at Twitter, and this was one of the first things I worked on. And over time, we kind of like got to a stable place. But there's sort of like interesting questions to answer. How do you think about rate limits in your GraphQL requests? One idea would be like, well, we'll do it based on fields. So we will apply rate limits to each of the fields in the schema. But when you do that, then you have more questions to answer. Or some fields are lists. So profile timeline, as an example, you might get a list of tweets. How do you think about rate limiting that? Because lists are variable. But then also multiple queries might reference the same fields. So how do you differentiate between different product surfaces on your application? How do you differentiate that and sort of like apply a rate limit that makes sense? That would be interesting to answer. If anyone has got some answers here, I would love to hear them. But we can kind of look at rate limiting in the sense of persisted queries, right? So when we use an ID to identify the documents we need to execute, then we can kind of visualize our GraphQL requests as disjoint virtual routes, right? And when we do that, we can now reason about them in the same way that we did our REST API endpoints. So we might be wanting to access, slash GraphQL ABC, and we can think of that as a route. It's virtual. We still have a single endpoint that exposes our data. But now we can configure our rate limits based on those virtual routes. And then things get even more interesting. So before I show you, actually, let's just do it in one go. Okay, so here, there's sort of like a bit of caution, right? So this is a GraphQL document. We talked about this. Now, documents can evolve rather rapidly over time. So developers are adding new features to your product surfaces. So every time you add a new feature, you get a new document ID. So instead of using the document ID as our unique identifier, we need something that's a little bit more consistent over time. So GraphQL provisions us to add an operation name. This kind of acts as, it's kind of like a function name to your query. So we can use this operation name to kind of like track documents over time as they evolve. And here, in a single document, you can have however many operations you want. I'm using this for illustrative purposes, but nothing stops us from requiring that every GraphQL query that we're writing should have a name. That's kind of a good thing to have. And then now we can use this operation name in conjunction with our GraphQL route. The ID becomes a wildcard, right? And any request that's wanting to hydrate our project timeline can now have a configurable rate limit. And the same for project contributors or any other routes that we might have or requests. And then we can also set defaults, such as if we don't have a configured rate limit, we can just apply some arbitrary default rate limit. Okay, so once we do that now, then we can come back to a somewhat familiar architecture as far as rate limiting goes. We have a client, it might send a few requests. Depending on the available limits from the config down here, we can decide whether we want to execute that request or not. So here we can do the same things that we're already familiar with as far as rate limiting goes. And our GraphQL endpoints from this perspective remains protected, so it doesn't see the requests that exceed the rate limit. Okay, so that's about rate limits. And now the next thing I'm going to talk about is another fun topic, breaking changes. I feel like this is one of the topics in GraphQL that can sort of like have opinions from like the opposite side of the spectrum. It's very easy to say never do breaking changes at all. Any breaking change should be, mitigated in some way. And I've sort of added like pre-production there as sort of like caution. Like, of course, when we're in production, we want to avoid making breaking changes. But sometimes they can be inevitable, right? Especially when we're working in a rapidly evolving environment where there's a lot of teams, Some of them are in ideation phase. They want to prototype and get something hands-on so that they can make progress and expand their knowledge on the topic that they want to build on. First, I went to the other slide quickly. Who can tell me what a break-in change is? True, that is true. But yeah, a break-in change is a non-backward compatible update to our GraphQL schema. So as he mentioned, this is a change that might actually break the contract that has been established between the server and the client. So examples could be something like removing a field, making an optional or nullable field required. So we can't do that because the server might return now where we are expecting a required field. This can cause some fun problems. Or maybe we change a field's type, right? Okay, so before I go to the next slide, caveat again. For break-in changes, of course, we want to make sure we're taking any reasonable measures to mitigate this, especially in production. We want to use things like deprecated life cycle that can sort of like point to reasons why we're changing, why this field is being deprecated, and maybe even information about what consumers should use instead of the deprecated field. We want to prefer new fields over break-in changes whenever possible, and we certainly don't want to make break-in changes and migrations a regular part of our workflow. That's just kind of like going to be bad across the board. But yeah, on the other hand, we also want to make it easy as possible to identify when a break-in change is okay, right? Especially when we're dealing with like development environments. So I think over the years of like operating a GraphQL service, for the first half of it, we took the stance as the GraphQL team. You cannot make a break-in change. But every once in a while, someone comes to you and says, I just published this change and I made a typo, or the spec has changed and now I need to change it, and I promise no one has seen it. I can put my heart on it. And then you're like, okay, sounds good. And then something breaks and now you've got a whole mess that you have to clean up. So then the question really becomes, why would you even want to consider investing into making it easy to realize whether a break-in change is okay? All right, so in development, break-in changes are kind of inevitable. Feature teams want to move really quickly. They want to prototype and iterate. And sometimes that means, you make the best decision you can now and you amend it later on. And it's quite difficult to get the first schema, your desired schema at the first go. Usually projects start on kind of a need-to-know basis. So you make the best decision today, you learn something new tomorrow, you update it. And then, right, so with that, requirements are going to change, kind of inevitably. So if you own a GraphQL service, where does that leave you? You kind of need to be in a position where you can provide enough information so that feature teams can make decisions independently without always pulling you into the loop, right? You being the GraphQL team, we want to make it as easy as possible to identify if a change will actually break a client. So this is the classic question of, if a tree fell and nobody saw or heard it, did it happen? You might have a break-in change, but if no client is consuming it, like surely, you should be able to make amends before they do. And in the case where someone's using it, how can you reason about the importance of that use case, right? What is the environment in which it's been used? Maybe it's in development, and one second. Maybe it's in development and the two teams are actually working together, right? Like in that case, it's fine. They should be able to work together and move quickly. So then how can we enable safer break-in changes? Okay. So the first thing we're going to do, we kind of like looked at this diagram earlier, where we have our query string there. We run it through a deterministic hashing algorithm, and now we have an ID. So this pair of ID to the actual document or the query is something that we have, and it's sitting in a database somewhere. There it is. It's got an ID, it's got some metadata. The other thing we have is our GraphQL schema, right? This is maybe running on our production server or something, but it kind of describes the state of our API. So we can get these two pieces of information. We can run the GraphQL queries, so as queries are coming in, we can pair them with the schema and parse them, and what we end up with is a reverse index here. So what we have here in this bucket here, we have each field in the schema, or rather, when we find a field that's been used in this query, we're going to pair it with the type or inspect the schema, and then we can pinpoint. This is called a field coordinate. So the type and then that's like the object, and then the field on the object together is a field coordinate, and that uniquely identifies a field in your schema. So this here, can I scroll? This field project here belongs to the query type, so that's query.project, and the same for project tagline. So we can parse that, and now we can look up a field coordinate and see what documents actually use it. Okay, so then equipped with this information, when someone comes and says, I would like to make such and such a change, we don't need to go back and forth asking, is this safe? Have you talked to this client? Is anyone using it? We can simply consult our reverse index here. So for the first change here, we've removed the tagline field. And when we look over here, we can quickly see that project tagline is used by a document called ABC123. So we can surface this information, and based on the usage, we can either reasonably deny this request to make that schema change, and the reason is because that query is going to break. Or perhaps if this is a new query that's come in and these two teams are working together, they can coordinate and make sure that this doesn't affect their development. On the other hand here, we have this schema change, and we've removed the name field. According to this little universe, no one is using the name field. So that's actually fine. It's a break-in change, but nothing is going to break. So we can actually let that go through. Okay, so this is just sort of like a note that break-in changes are break-in, but when no one is using it, or you don't have a strong enough use case, and people are experimenting and prototyping, that's actually okay, and you can safely make a break-in change. Okay, so let's see. I actually intended to skip this slide, so I'm going to do that. But that is also a fun topic. Okay, so we've sort of like looked at different examples of how we can use persisted queries, right? They sort of give us this window of opportunity to reason about many aspects of our GraphQL service, or rather the GraphQL ecosystem, allowing us to build some powerful extension points that can help us offload the burden that is placed on the GraphQL team. But as with all things, we're always making a trade-off, right? So in this case, it's a trade-off of simplicity in one area, such as doing rate limiting or allowing for safer break-in changes and metrics, but we're also introducing complexity in a different area. So the next thing we're going to look at is some of the trade-offs that we're making when we choose to go down this path of using persisted queries over string queries. So obviously, this is kind of maybe self-explanatory, but Building everything that we just talked about can take a lot, big investments from the GraphQL team, years even, to arrive at some of the topics that we've talked about here. But sometimes it's worth it, right? And that's sort of like a call that your individual teams would have to make. So we're also introducing complexity in our client build processes, whether this is talking about building in the tooling that's going to persist the documents, understanding when your repository has got a new document versus when it doesn't. You kind of don't want to do duplicates, or maybe you want to, but that is still a complexity you have to sort out. We might also build in potential friction points into some of the more popular client libraries like Relay or Apollo. These tend to have a somewhat stronger opinion on how you should do your GraphQL, but they also provide great benefits, right? So if we choose to go down a not so popular path, we might have some friction when we want to use these libraries. Now, this is somewhat maybe one of the bigger trade-offs that we make when we choose to do persisted queries. We're also giving up the ability for the client to dynamically choose what fields it's going to execute at request time. And with GraphQL, this is kind of like one of the biggest touch points, right? When we had REST APIs, we just get all of the data back, and then we have to sort through what we actually want. But GraphQL allows the client to select what fields it's going to hydrate. Now, when we fix the queries that we can execute, we actually give that up. There's kind of ways that we can sort of like work around that, which I won't go into today, but it's an important trade-off to keep in mind. Okay, I also intended to skip this slide, but we can talk about it. So because we're sort of like giving up the ability to choose what fields we want to execute, we might kind of like imagine a scenario where we started out our schema, we had a user and it had a name. And then over time, we decided, well, actually, we want to split up that name. We want to have a first and a last name. But on the client side, we sort of want to do this gracefully. We don't just want to like skip over and switch. We want to have a fallback. So in this scenario, we might do something like, this is skip and include directives, which come built in with GraphQL, most of the GraphQL libraries anyway. They sort of allow us to conditionally hydrate a field based on a Boolean value. So to achieve the same thing, but if this is a query that's got an ID, we can't just like decide to hydrate those fields at runtime. We need to put in a persisted document and then hydrate it with the ID, right? So to achieve the same thing, we might do something like this. We might say, all right, if skip name, this is a Boolean flag. If that is on, you might think of this as a feature switch that we want to toggle on and off based on, maybe we want to run this through A/B testing or something like that. So if this flag is on, then we're going to instruct our GraphQL service to skip the singular name value. And then we're going to grab the first and last name. And then when it's false, then we want to skip the first and last name and include the first name, the singular name. And that sort of like brings us back to this query that we have here. Now, you can imagine this sort of like at a large scale. You have different teams that are sort of like experimenting, and this can get pretty bad. There's sort of like ways we can elevate this pain on the client side, but it can get like pretty bad. So that's sort of like something to keep in mind. Okay, so I won't go into some of the ways you can like tackle this, but if you're curious, we can chat after. Okay, so let's talk about what we've covered so far. So we started off by talking about persisted queries and some of the contextual data that we can store along with them. We looked at how we can use that metadata to derive some insightful visibility on our metrics, and how we can get some coarse and fine-grained metrics to observe how our GraphQL API is running. We talked about how we can reason about rate limiting in this universe on a per operation or document ID basis. Then we looked at how we can use the data that we have available to us with the persisted document storage and convert that into a reverse mapping from field or field coordinates to document ID, and that can help us quickly answer some of the more challenging questions, such as, is this a safe change to make? And then we talked about trade-offs, right? And that covers all of the topics that I had for you today. So yeah, thanks for coming, and now we can open it up to questions.
Yeah, thanks for the presentation, first of all. It was really nice. You described a lot of really cool features, like all these things. But are they implemented in the library, or do we have to implement everything ourselves from scratch, essentially? Which is something you kind of mentioned in the last slide with trade-offs, but maybe there is something.
Yeah. So at Twitter, most of this was custom implemented, but libraries, like I mentioned, Apollo now has support for persisted queries. It's sort of like similar, right? So it's the strategy where you have a persisted query that's cached. It's not stored permanently, but it's cached. So I think like some of the Apollo is starting to sort of like building some of these features that you can just sort of like use out of the box. But yeah, I think like for most of it, you might have to do some implementation. But even for stringed queries, things like metrics, for example, there are ways to get at the same data. It just may be not as accurate. So I'll use Apollo because that's the one I'm most familiar with. But they have like support for telemetry tracing. But if you're receiving large volumes of requests, you kind of have to sample. So you get like a rough estimate that might be good enough for you.
So obviously you talked about once you implement that pattern of persisted queries, like that brings a whole new level of like maintenance of that cache of documents. Do you ever in your experience, did you ever put some of the responsibility to maybe the teams who wanted to query the schema to own their own persisted queries, or has that always been something that like you as the GraphQL API owner would create?
Yeah. So it was something that the GraphQL team owned. I think the goal was always to think about how can we make it easy for the feature teams or the client teams to get at some of the answers that they had when we had REST APIs, right? That was sort of like always the goal. So hashing the queries is actually like not that difficult, right? You can just sort of like get a SHA-256 and you have an ID. You just need to normalize it. And once you do that, anyone can get a document, run it through that hashing function, and you come back with the same ID. So that's like sort of like not too bad. But yeah, the more interesting things came from, I'm a client engineer and my job is to work on the profile timeline. I want to know how the profile timeline is doing. When there's a success rate dip, I want to know that information. So it was always pushing back that information to the relevant teams that might be interested in. And when we didn't have that, when something breaks, the first place everyone looks is GraphQL team, this thing is broken. And then you have to do some work, and then you realize, well, the GraphQL service is fine, it's this dependency down the road. So that's sort of like the more challenging parts of the game.
Yeah, no, yeah, and then I guess maybe just to follow up a little bit, would you then almost be in a position where if one of those feature teams would have a specific like requests for certain data points, you would then create on demand the queries, or would it always be you sort of driving? Okay, no, we own the access. We determine like from the query design perspective, I guess.
Yeah. No, it's sort of like, so things like observability, where like you publish metrics into dashboards, all of that was sort of like already there. So like I mentioned, it was sort of like surfacing that up. Michelle, I'm going to put you on the spot. But so Michelle and George are my colleagues, and they worked on some interesting features where you can get a dashboard and take a query, right? And using some of the building blocks that we have here, you can sort of just plug it in and see how it's doing across the board. So how is this field over here doing? And if that field is broken, what else is broken, right?
I see. So expose like a subset of the fields, and then people can run whatever they want. Okay, nice.
So yeah, like I mentioned, I think like just sort of like overall, we always want to like, we have data available to us, and it's always the question of, independent of our team, you know, if I'm on call and I'm asleep, do we have enough information for someone to go and look at a dashboard and not wake me up so I can point them to it?
So hopefully this is really straightforward. Is this not the same as a prepared statement in SQL? Prepared statement in SQL?
I'm not too familiar with SQL. What is a prepared statement?
Okay, so prepared statement is just a compiled SQL statement that has parameters for the variables you're passing into it. So for example, the ID that you mentioned in your example, and it just allows the database to, it knows the query plan so that it can extract the data and it's more efficient. It's just a optimization. So it seems to me it's just the terminology seems to be the same thing.
Sometimes you call it store procedure. Store procedure is the same thing, no?
No, store procedure is more executing a block of code within your database, whereas a prepared statement is executing a query that is pre-compiled. And all you can do with a prepared statement is pass parameters into placeholders in the prepared statement, but it's faster than executing the raw SQL directly.
Yeah, I think that sounds very similar.
Yeah, okay. So, which makes a lot of sense. I mean, yeah.
In this case, we can execute the GraphQL string query, so the client can say, here is a piece of text that represents my query, and then we can execute that. Or with what you're describing, we can have that document ahead of time, right? And then we can parameterize it, and then we can send that ID back. Okay. Thank you.